How is this possible? The approach that we took was to start to think about where the architecture was going to go. We defined the architecture to be mixed critical from the get-go. We decided about 3 years ago that the rate at which AI is expanding, it would be unnatural to separate the infotainment system from the ADAS system. These are, at the end of the day, taking into the vehicle sensors that the car is seeing, consuming it through AI. Yesterday it was computer vision, it was classical AI. Today it is called a VLM, tomorrow it will be called something else. But it really is the car being able to detect its environment through the lens of AI and then feeding it to various consumers, whether the consumer is the ADAS system, whether the consumer is the cockpit, or some combination thereof. Now, because the car is a safety product, it is designed inherently to be safe. We have to be able to think about this with the safety envelope all the time. We decided 3 years ago that we are going to over-dimension the silicon. We're going to build the most capable SoC that the industry has seen. We're going to do this on the cockpit framework. We're going to do this on the ADAS framework. And for customers that wish to do this together, they will have the flexibility, which is why we call it flex, to be able to go do this on the same exact platform. And you can see the multipliers. You can see how much we have grown the capability across really every
Yeah.
dimension, across displays, across CPU cores, across GPUs, across the NPU, across the number of sensors we can support. And this over-dimensioning is something that we converted into a chip that we supplied to the China ecosystem for the first time in January of 25. Here, sitting in June of 26, we see cars on the road. So first of all, a big thank you to the China ecosystem for embracing this capability and putting this on the road. Now, if I bring together everything that I've said so far, the Flex architecture gives you the best of both worlds. It allows you to be able to take cockpit capabilities and ADAS capabilities, run them concurrently. It allows the work, more importantly, the software work, the hardware work, the testing, the ability to be able to build a model that is running on our silicon, make it binary compatible, allow it to be moved from one silicon to the next silicon, fundamentally accelerate the rate at which technology is moving, your software is being developed, and bring in a tremendous amount of flexibility so that you can reduce your overall system cost, so that you can take development that you did in the previous generation and carry it over to the next generation, really independent of any domain. The architecture is mixed critical, it is flexible, and it allows cockpit and ADAS to coexist. This also allows you to be able to very quickly move towards an agentic world, because now on the same underlying platform, you have access to every ADAS sensor, every cockpit surface area, every microphone, every display, everything inside the cabin and outside the cabin. So to be able to run an agentic framework on top of such a platform makes it very straightforward. We've been very fortunate to work with some of the best companies in China, and I'll show you here an example of Deep Route running their stack on a leap motor vehicle on the 8797. This is commercial today. I want you to pay attention to this because this project was executed within about 6 months of the customer receiving the platform. This required very close coordination between Leapmotor, our OEM partner, Deep Route, our stack partner, integrating it onto a brand new platform and deploying it commercially. This platform is now deployed on the road. The reason this thought process is so important is the rate at which the innovation is happening is independent in every area. Companies that are evolving their stack are moving very quickly. Companies that want to be able to go move to a hardware architecture are moving independently very quickly. The ability for us to be able to mix and match a partner who's working on a stack versus an OEM who has selected a new car architecture and get them to start to work together to go deploy something and within months make this happen is testament to the capability, the flexibility, the versatility of the China ecosystem. It also has a lot to do with the way that the car architecture has evolved and how silicon and software architecture is evolved. We are very excited to say that in China, last year, we accomplished our first 8775 Flex launch with BAIC. This was a result of tremendous work that was done by our partner Autolink and our partner ZYT, who we've been working with again independently for a number of years. But this came together in this partnership where between BAIC, who decided to deploy the 8775, one of our first engagements with BAIC, and of course with Autolink and ZYT, who've been our partners for a long time. We've had 9 different flex wins, and we expect to see, as we deploy Gen 5 over the next couple of years, a lot of flex deployments to start to take off in China. I would now like to invite Vice General Manager of BAIC, Mr. Yu Liu, who's been a new partner of ours, and we really welcome BAIC to the Qualcomm fold.
有请北汽集团副总经理刘宇。Welcome, Liu Yu.
各位同仁、各位伙伴，非常荣幸今天能够参加高通的这个年会。应该说，作为一个汽车企业和一个世界先进的半导体企业，能够有很多项目上的合作，是我们面向未来的一个趋势。那么，我今天想跟各位一起介绍的，其实是我们谈谈芯片。刚才说了有一个 Flex 架构的8775的芯片，那么北汽集团呢，我们去年量产了全球首款基于 Flex 架构舱和架一体的解决方案。我们在极狐 Alpha Tube 上，我们在这里呢，我想跟大家一起分享一下我们尝试全球首款搭载的这个方案，我们的整个的开发过程。我们把时间的指针调回2024年 Q4。其实那个时期我们面临的问题是，高等级辅助驾驶已经大规模量产，那么大部分的搭载的车型都是在30万以上。那么我们理解辅助驾驶，尤其是高等级辅助驾驶，我们常常讲的城市 NOA 应该是车辆的标配。无论是50万的车、30万的车、20万的车、10万的车，甚至更便宜的车，都应该成为标配。我们在汽车的发展史上，我们已经看到了，当年我们认为是高配选配的 ABS、ESP， 现在都是标配。所以基于这个想法，我们就想，那我们10到20万这个区间，尤其是以12万作为入门价到20万的这个中档家庭用车和搭载高等级辅助驾驶，这是我们一个巨大的挑战。我们知道好的东西都贵，硬件吃了很多的成本，座舱跟自动驾驶2颗芯片、2个预控、2套供电系统，这是一个巨大的挑战。那么在2024年 Q4， 我们还遇到当时发生一个现象，就是从 BEV 到端到端，无论是两端式还是一道式，从基于规则、基于代理到基于模型的整个的智驾方案再进行变革。我们那个时候听好多的行业的专家或者同事说，我们在思考要不要删代码，是继续走规则制还是走端到端。同时在汽车电子行业一直有一个理论来指导我们前进，就是电气架构的进化。那么应该基于中央计算，基于软硬的结耦。所以在当时这个环境下，我们恰恰是在这个城市无锡，我们召开了一次技术研讨会，那么坚定了我们在这个方向持续推进的决心和信心。所以我们可以看到，我们应该是锁定了目标，我们应该找到解决方案。 所以我们开始找从芯片、支架方案到预控到项目管理，我们自己也做了一些工作。北汽我们在智能化这个维度，我们自己做了一件部门整合的事情。我们知道很多车企，座舱和智驾是两个团队，两个独立的研发团队。我们一直是坚持是一个团队，我们由一个总监来负责。所以在这个基础上，我们认为搭载8775这颗芯片，推动舱加一体的解决方案具备了条件。所以我们形成了这么一个4方的开发的合作团队，北汽负责需求定义、项目总控、集成、验证，高通提供底层芯片的解决方案。那么车联天下作为预控的开发者，高强度推动项目落地。同时我们还联合了卓越，就城市 NA 把模型做小，把体验做到位，进行了联合的策划。大家知道8775这颗芯片的 NPU 稠密算力只有72T，在现在动不动上千 T 的高等级自动驾驶这个解决方案的需求下，72T 如何满足消费者的需求，这也是一个巨大的挑战。所以我们4方联合团队在去年2月19号立项，我们10月30号极狐阿尔法 T5首款车量产交付，我们就用了8个月的时间。那么整个的心路历程应该说是很纠结，挑战很大的。我们有很多行业里的朋友告诉我们，你们不要碰这个。2个底层架构，2套系统，大量的数据的通讯、握手，车辆高等级辅助驾驶要求毫秒级，而座舱没有这个需求，这个是走不通的路。我们想，既然是选择这个路线，我们就要把它跑通。所以4方团队把它实现了量产。我们现在不光是极狐阿尔法 T5， 极狐阿尔法 S5， 包括我们刚刚发布的问道 V9， 都搭载了8775的这套方案。那么我们可以看到，我们在去年极狐的业绩翻倍式的增长，我们消费者的对于这方案，尤其是城市 NA 的体验是非常愉悦的，而且我们也进行了很好的控制，尤其是面临这个芯片和内存都在涨价，我们共用的是一套内存系统。同时我们也为企业开发的标准流程积淀了经验。那么面向未来，我们还是要就芯片说芯片。我们认为下一代基于 VLA、基于世界模型训练的高等级辅助驾驶会进一步的对算力有要求，所以舱架融合这条路线，我们认为是可以走的。同时，应该这个平台不断的升级换代，那么增加的不光是智驾的能力 ，AI 的能力也要加进来。所以我们现在畅想一下，新一代我们认为就应该在今年年底，27年以后，我们应该是这是新一代的标配的方案。在辅助驾驶方面，车更懂你，跟城市、跟环境之间都是平滑顺畅的互动，语言这个通过语言来指导驾驶，这应该是没有问题。同时，我们就应该在座舱里塞进更具智慧的大脑，可能就像贾维斯对钢铁侠一样，无所不能来辅助。所以我们也希望，这是一个生态，不光是从芯片开始，从解决方案到整车的定义、开发，包括用户的使用环境，形成一个定义、开发、持续迭代的工作环境。 为消费者提供更加完善、更加满意、更加安全的解决方案。谢谢。
Thank you very much, Mr. Liu. His partnership with the BAIC has been fantastic. I had a chance to ride in the vehicle myself a few months ago, and it was a fantastic experience. We are really delighted to have Flex already on the roads in China. I'd like to draw your attention to connectivity. And we've been supplying connectivity into cars since the early 2000s when CDMA entered into North America. Today, we are starting to see satellite connectivity becoming a requirement in a number of different mission critical, commercial, far flung areas. And as the number of constellations with connectivity increase globally, we start to see this as yet another new level of innovation. We've been driving the connectivity block inside cars for a number of years, and we believe that this is actually going to be a really interesting way to have yet another modality, yet another link back to all these connected vehicles. I would like to share with you a little bit about what we are seeing in the car in the context of AI across other use cases. The car is becoming this platform where there is so much of content, there is so much of data, there are so many insights to draw from everything that the product is capable of, that using AI inside the vehicle, outside of use cases beyond driving, beyond the in-cabin experience that we talked about. These are use cases that are relevant for the car itself. Automakers are continuously interested in trying to figure out how to get early warning information so they can spend less on predictive maintenance, so that they can reduce their warranty costs. And we are starting to see, as part of the efforts that we are driving through Edge Impulse, which is a machine learning ops platform that we are deploying inside the vehicle, the ability to be able to collect data, whether it's time series data, machine learning data, run local models, and extract insights, extract intelligence. We are still continuing to use the same NPUs that sit on our platforms, and this allows us to be able to add yet an additional layer of insight from a machine learning and AI perspective. I would like to now welcome Jeff Zhang, Chairman of Banma Intelligence. Banma has been a fantastic partner of Qualcomm for many, many years, but especially now in the age of AI, as we start to think about how new models, advanced models like Quen, how new use cases and experiences from e-commerce to bringing mobile experiences into the vehicle, doing it where you have cloud and edge working together. How does this all come together? I would love to have Jeff share his vision with us. Jeff Zhang.
有请阿里巴巴集团合伙人、达摩院院长、斑马智能董事长张建峰。Welcome, Jeff Zhang.
今天非常高兴有这么个机会来分享一下，我们斑马在做的一些事情啊。大家肯定会很奇怪嘛，我为什么会代表斑马来讲这个事情啊？因为阿里巴巴大概在14年的时候，那时候我们提出了一个概念啊，叫互联网汽车啊。因为那个时候互联网应该是发展到一个最顶峰的这么一个状态啊，特别是阿里巴巴自己的电子商务业务也发展的非常好。然后呢，那个时候也是人工智能啊，我们深度学习的人工智能为代表的这个技术啊，也刚刚兴起的时候。那时候呢，还有一个这个背景啊，就是这个 OS 啊，特别是手机为代表的各种各样的操作系统，也是一个兴起的时候啊。所以当时有个想法啊，能不能让这个汽车啊变得更互联啊，更可以跟这个像阿里这样的一个巨大的生活平台有个连接啊。然后 我记得很清楚啊，那个时候我们第一次的想法是想把地图作为一个智能座舱的这么一个核心啊，然后花了很大的精力啊，在做一个我们自己的阿里的 OS 系统啊。当然，那个时候我觉得各种硬件啊、条件啊，都还是有很多制约的啊。我记得座舱也是像高通这样的，原来从移动端的平台平移过来啊，不像今天。今天我看我们最主要的是像高通还推出了专门的一个智能座舱的解决方案，也有个专门自驾的解决方案，这是个行业的一个巨大的这么一个进步啊。所以从2020年我们推出这个智能座舱到今天，也经过了大概10多年的一个时间了，这个行业也发生了翻天覆地的变化啊。当然，这个技术也发生了翻天覆地的变化。大家知道，从个我原来是这个工程师出身，我编码啊。从这个软件这个系统来讲，也发生了很大的变化啊。原来不管你是互联网还是什么，实际上都是以数据为中心的啊，以数据库为中心的啊。我们无非是在读取信息、处理信息、写回信息啊。大家其实本质上都在做这么一些事情啊，交互大部分都是指令式的，大概这么一个系统啊。所以那个时代就很简单啊。大家想一下，如果有这么一个格局的话，谁会是这个里面最好的，对吧？像数据库，那肯定，对吧？因为所有的系统都围绕它在做啊。那今天我们都在讲人工智能，对吧？那人工智能发生了非常大的一个变化，我认为对软件工业或者系统会带来一个根本性的变化。因为现在的整个系统它都不是围绕这个数据库啊，或者是这样的一些基础性构建起来的，它是围绕着一个智能。所谓的 AR 啊，AR 最重要的能力是什么？是推理所以它是基于这个推理的能力构建起来的啊。所以我觉得以后所有的系统啊，它都会重新围绕着推理啊，你的尊重啊，这里有个推理存在的啊，比以前的系统更 power 啊，比你的人的能力啊更强啊。所以所有的系统都在解构啊，我把我原来的系统需要用到推理的部分都得交给这个所谓的大语言模型，对吧？那我以前做的功能是什么呢？我以前的功能我都需要 agent 化，对吧？agent 化之后完成专门的工作，完成专门的工作之后，那怎么完成更好的完成专门的工作啊？现在又发明了很多新的词啊，有 skill， 对吧？还有编排，还有 crawl 等等一堆的东西啊。那刚才这个Nakul也好，很多前面的分享也好，他们都提出了一个非常好的问题啊。我有非常好的算力啊，我有非常好的基础设施。那我怎么构建这么上面顶层这么丰富的应用啊？这个就是我觉得是我们斑马啊这样的这个服务商应该存在的这么一个价值啊。大家也知道，这个现代工业文明的这个最重要的一个贡献就是分工啊，大家做擅长的事情。当然，我知道现在中国有很多的汽车厂商，它是垂直一体化啊，他们也有可能做得非常成功啊。但我觉得分工并不是分蛋糕，对吧？分工肯定是创造新的价值啊。我们为相互赋能啊，让这个行业变得更繁荣啊，也让这个行业变得更富有创新力啊。这是我觉得我们的这么一个宗旨啊。虽然阿里也做芯片啊，我们的达摩院现在也做芯片啊，但我们没有做汽车芯片啊。我们认为这是个非常专业的这么一个行业。那我们现在接下去想做什么，对吧？我们认为应该做什么？那我们再看这个汽车智能座舱这个领域啊，包括自驾啊，发生了什么一些变化啊？智舱这个领域啊，因为它毕竟是一个车，对吧？我人在这个回路里面啊，我们现在把系统可以分为人在回路里面跟人不在回路里面啊。人在回路里面的系统，它需要感知这个世界啊，所以我们的汽车作为这么一个物理载体，它肯定会有越来越多的感知能力啊，包括语音的啊，包括空调温度的 ，anyway， 很多都是具备这个感知能力啊。具备了这么多感知能力之后，我怎么样去让它变得更有智能啊？我觉得我第一步要融合这些所有的感知，对不对？第二，我要去推理，对吧？我要去决定做什么啊，这个就是要做给一个语言模型可能要做的事情。第三，我要去提供一个服务啊，我怎么样把这个拿到的感知啊，我作为一个智能的一个推理，我能够得到一个什么样的一个结果啊？那所有这套东西，我觉得又要一个新的这么一个系统啊。这个新的系统存在的核心目的，就是为了屏蔽上面复杂的东西啊，然后为了上面的一个应用开发啊，提供更有价值的、更有性价比的这么创新的这个手段啊，让我们的 客户能够开发的更快啊。当然，刚才北汽的这个刘总也讲了，我们原来可能要8个月啊，要很长时间，我们现在可能要缩短到3个月，对吧？因为我们很多工作都可以做掉啊。那在这个角度下呢，我们在想啊，那汽车跟一般的大语言模型推理有什么本质的区别？那我认为在车里一个非常非常重要的啊，它需要一个非常低的延时啊，要一个非常自然的那个交互啊。刚才我讲了，我们也没有完全做到，我们在这个往各个方向努力啊。你不能要唤醒它啊，你也不能跟他讲一句话，然后要等一会儿他才有这个反应啊。你不能什么事情都要你主动去发起啊，类似这样的事情是非常非常多的啊，所以我们叫主动智能啊，这个是低延时啊。然后车我的模型又跟大语言模型不一样啊，因为大语言模型大家知道，现在提供大语言模型的厂家都在往深度、广度方发展啊，因为他们要完成长程的任务啊，因为他们要做长程的推理啊，他们现在的目标就是说我能够连续工作24小时，在一个任务上啊，能够不间断，能够做完啊。但汽车显然不是这么一个场景啊，汽车可能就是我提供跟车出行目的有关系的啊。跟出行本身有关系的啊，包括情绪价值，对吧？啊，包括一些出行的目的地啊，包括一些娱乐这样的一些服务相关的啊，这个跟那个优化目标是不一样的。所以我们提出来的目标就是我们要在车侧、在端侧能提供一个非常精巧的模型啊，它的核心就是要服务出行本身，服务车本身啊，当然提供极低的延时、极低的这个成本。所以这个是呢，我们也推出了我们自己的叫做 Automotive 的这个大语言这个模型啊。然后呢，我们下一段我刚才讲那个智能这个范式，对吧？在阿里这个跟斑马的合作啊，斑马给各个车上的合作，我们核心的基石，我们还是提供一个阿里 OS，对吧？我们希望对下面屏蔽硬件的这么一些复杂度啊，提供一个非常好的这么一个操作系统。那这个操作系统今天高通也在讲了，我们要融合，对吧？我们要这个算力啊，要这个在安全上要有隔离，在智能上要有这个支持这个大模型啊，当然还要有数据隐私的保护等等啊。这个就是我们希望能够提供一个基础的 OS， 然后上面提供一个基础的能力啊。再往上面，我们希望能够提供一些我们能提供的原生的应用啊，包括我们去整合服务，因为互联网的服务非常多，对吧？娱乐的服务也非常多啊，也并不需要每个厂家都去对接一遍啊。我们希望整合这些标准的一些互联网的应用的服务啊。第三呢，我们希望在这之上，我们的合作伙伴能够开发自己的个性化的、定制化的应用啊，这就是我们这个斑马希望能去做到的一些事情啊。好，那今天呢，我觉得也是非常有这个感谢啊，有这样的机会认识这么多的汽车的同仁啊。听了前面这位分享之后，我觉得我也更有信心了，对吧？高通我们提供了今天一个非常好的算力平台啊，像斑马这样的一个提供了一个非常好的像 OS 啊智能的这么一个原生的原生的面向未来的这么一个操作系统啊，然后我们提供基础的应用。然后再跟我们的合作伙伴一起啊，来丰富整个汽车的应用生态，加速这个创新啊！谢谢大家。
Thank you very much, Mr. Zhang. We are so excited to be partnering with Banma Intelligence across Quen, across iOS, across creating so many different experiences. And this is an example of how, as the industry moves from software-defined vehicles to AI-defined vehicles, these kinds of partnerships are going to be game-changing. So again, very happy with the way that our partnership has evolved with Banma and a lot more to come in this space. I'm getting towards the end of my presentation. We are so excited about being part of this ecosystem. And when we started to think about the China ecosystem 5 years ago, it was really a very step-by-step, put one foot in front of the other, engage with customers, engage with partners. This entire ecosystem was quite foreign to us. The approach that we took was The ecosystem obviously understood Qualcomm, understood Snapdragon. We have a very large team in China that has been working with the China supply chain, the China electronics ecosystem, the software ecosystem, the cloud ecosystem for a number of years. And I feel like what we see here 5-6 years later is really a result of the entire China ecosystem focusing on EVs, focusing on automotive, focusing on AI, focusing on building new car architectures, and being able to bring all of this together. So for that, I thank all of you. We deeply appreciate it from the Qualcomm Automotive team. And thank you to every single one of our partners who's done such a fantastic job in being here and being able to support us and being able to make the impact that you have. Thank you very much, Shishe. I'd like to now welcome my colleague Anshuman Saxena.
感谢Nakul先生以及各位嘉宾的精彩分享。接下来，掌声有请高通技术公司副总裁兼 ADAS 与机器人业务总经理 Anshuman Saxena 先生。Let's welcome Anshuman Saxena.
Ni hao Shi. Good morning, everyone who's visiting us here at the Qualcomm Auto Summit. It's great to be back. Fourth year in a row. And looking at the stage, looking at everything that is happening over here, it's just so exciting. I talk about scaling the intelligent driving. Nakul covered a lot of what we are doing in the overall automotive, but I'll focus a little more on the intelligent driving, which is basically ADAS and beyond kind of a thing. But before I start any of that, I just want to thank everybody, all the automakers that have given us an opportunity, embraced our solutions in China, globally, picking up Snapdragon Ride solutions. It was in 2023, we came here, I came on the stage. We, of course, had a cockpit business that was going on, but it was new for Snapdragon Ride, and the China ecosystem was like, okay, good, but what have you got? And since then to now, we are there in majority of the automakers shipping based on Snapdragon Ride, and it's not just because of the product is good, but it's a humble feeling that the ecosystem allowed us to give us an opportunity and trusted us, which we are delivering now. So really appreciate that. Thank you for that. With that, how are we seeing the whole AI evolution inside the company? And this is important because that kind of drives how we are approaching the problem statement across the board. We, in the ADAS world particularly, started with the traditional perception solution, CV solution, classic AI, and trying to put the cars on the road with active safety level 2 kind of functions. At the same time, there was a lot of enhancement that was happening on the interaction with the cockpit, with natural language processing, basic AI capabilities, but now more and more generative AI, large language models coming in to interact with the vehicle, that kind of applications. But the idea of sensing with reasoning, being context aware, and doing actions on that, that's really what is happening. The technology is changing. We are embracing the tech, the innovations from the industry, and continuously innovating on our side on different compute blocks, different solutions, leading to automated driving, automated vehicles, eventually going towards a level 3, level 4 system, and not stopping at that. We are expanding physical AI towards the next realm, the next era, which will be with the robotic solutions. Actually, I had an opportunity, a privilege to connect with a lot of the robotic companies as well over here. But that's a logical extension for us to move from sensing to now going towards a full physical AI implementation. If I step back, zooming into the ADAS side of the things, the automated driving side of the things, we used to do all these individual sensor solutions going towards the multi-modality BEV applications, putting it together in the car and doing some action planning based on the rules-based implementation. That was actually not too far ago, being in 2023, 2024. over here and in the global solutions. That's really what was happening. But with the increase, with the change that has been happening, multimodal perception, language models coming in, the vision language models coming in to start doing much more with the same sensors is making a big difference. That's the next level of intelligence that was embraced in the automated driving system. But actually, what is happening now, and I'll talk more about it during the rest of the presentation, end-to-end deployments with vision language action models coming together, connecting with the agents that are there in the car for other reasons like cockpit and actually feeding it into the system for automated driving. That's really what is the technology solution that is looking like. And we are building our parts, our solutions, our semiconductor solutions based on that. Not just that, the whole software ecosystem that we are putting together around the SoCs is designed to bring in these capabilities into the car. And the fastest way to see this is actually here in China, where we do these developments and deploy it on the Snapdragon Elite kind of processors, which we'll discuss in more details. Now, if you look at it, what is happening in the ADAS world, we just talked about it, but actually in the cockpit systems, Nakul covered a lot of it. There is still a scalable range of solutions that is required. There are vehicles which are having limited display capabilities and audio capabilities, all the way to multi-displays. Some of the esteemed guests who talked about it, they showed what all they are bringing in the capabilities of the cockpit of the vehicles, all the way to 8 displays. But actually, displays are just the surface. What is happening really is the what you heard in the Banma intelligence presentation by Mr. Zhang, that there are these agentic implementation, agentic clause that are coming together, and they have to be co-hosted into one kind of a system. That's what is driving the next level of compute that is there. Same way, if I look at it from the ADAS perspective, we know that there are reasoning solutions that are there. VLAs are getting deployed, but there is a difference of having a VLA with a small token rate to a VLA which will be really complementing the action. The compute requirements are very different. Sensor requirements are very different. We are going towards a level 3, level 4 system. Sensor requirements are different. The resolutions are different. So overall, there is a scalability that is coming in. One central piece in all of this is software investments are the maximum investments in this development. So our goal is to maintain scalability from the left-hand side to the right-hand side, where we have got entry tier solutions to the premium tier solutions based on a single chassis kind of a platform. And how do we do that? We came here talking about Snapdragon Ride Flex a couple of years ago. Last year I was here, we talked about Snapdragon Ride Elite processor, primarily targeted for ADAS and similarly for the Cockpit Elite processor. But as of now, we will see actually a lot more deployments on Snapdragon Ride Flex solution based on these Elite platforms, where we will have all the way to city navigation based on VLA-like implementations and agentic AI, the multi-agents running in the car at the same time on a single platform. How do we do that? I'll talk about it briefly, but this is really the future that we see. And as we go into that, the way we understand the automakers, the ecosystem is looking at it, is they are looking at, again, the scalability across the board. As I said, last year we were talking about Snapdragon 8775 as a flex solution. It will be coming to production. You heard Mr. Liu talking about BAIC's ArcFox as the MPVs that are some of the first deployments based on the Flex solution, which was perfect to bring in a cockpit system based on our 8155 and the other ADAS solutions merged together into one 8775. That is the baseline today beyond our standard ADAS and cockpit system. Now, at the same time, we started working on Snapdragon Ride Cockpit Elite and the Snapdragon Ride Elite and the Snapdragon Cockpit Elite, which Nakul mentioned that we had this deployment on the Leap Motor D19, dual device controller, one simple controller. It is already gonna be offering in the order of 2,000 effective TOPS, equivalent to many other platforms that exist. That's the extreme of the platforms that are being deployed in 2026 in China. And a similar thing will be repeated in the global ecosystem too. It can host VLA-based automated driving, end-to-end implementations, as well as the agentic multi-agent clause that are going to be are available on the platform. So it replaces big compute of cockpit and a really big ADAS compute into a common platform. But the beauty is here. We are basically working on bringing it down to a single 8797, which is back to the Flex architecture. The same hardware development cut down by half, same software development that can be merged together without really investing a significant effort, can be brought into a Flex implementation on the same 8797 device. Why? Because we designed these solutions from get-go to host a cockpit and a ADAS at the same time. And to fill up the gap on the lower tiers, we have got the new additions on the Elite family, where we will be bringing in all these capabilities into our next 8787 like process. If you look at it, it's one thing to merge these things together, but it's not the complete story. The idea of Flex is to bring differentiated experiences, giving you a lot more performance. 8295 has been a great platform for cockpit here, but if you go to 8787 or 8797, we are talking about the two platforms merged to one, giving you anywhere from 1.5 to 2x performance increase in the mid tier, and 3x performance increase in the higher tier, going all the way to a dual controller. So, one scalable, unified compute platform roadmap, reusing all of the software and hardware investment. By the way, this is the same story that we see that when you go global with the China vehicles, this same solution can work with a different set of stacks outside. How is it all possible? Again, big thanks to very ecosystem of stacks that the automated driving stacks that we have been bringing and enabling on our platforms. As recently as earlier this year, we have one of our flagship OEM vehicles, the GAC Ion N60, driven by the VRide stack on 8650, has been on the leaderboard for the best scores for the performance tests. This shows that we can bring in a lot of capabilities on our current Snapdragon Ride platforms, and imagine this all can be enhanced multi-fold when we go to the Ride Elite and the Flex platforms. Deep Route, that is a platform, a solution that is running on our Elite platforms already, on the vehicles deploying VLA stacks already in the car. We announced with Wave a partnership which is for the global ecosystem. Momenta has been a great partner. So again, really engaging partnership with all these stack suppliers and then partners from ZYT, QTOP, etc. Deployed at scale on the Snapdragon SoCs. And this is working on a varied ecosystem of the hardware tier 1 partners, bringing in sensors and all the capabilities. The most important piece is all these systems are getting deployed in 6 to 9 months from the time that the award is announced to the time the cars are on the road. So that's the ecosystem that we have developed, and again, thanks to all the partners over here. Now, this is not a new picture that you might be seeing, but important piece to understand on this is the more we work closer to the deployments of the vehicles, the more we understand and learn what can be improved. I'm not going to talk about the Oran core CPUs and the great NPUs and the 1,000 tops effective, etc. Think about it from a system perspective. What do we take away from all these engagements, the learnings that we do every month, every second month over here? We have been investing on bringing in capabilities of sensor processing. You need to implement safety implementations independently on these elite processors. We had put small compute blocks for sensor processing. They are completely independent, not counted in the big AI engine which many GPUs, etc., might have. This is a dedicated block where you can have a LiDAR pipeline or a camera pipeline to do a separate implementation and deliver a safety use case. All this goes in the planning as we make these compute units into our elite platforms. And this leads to this mixed criticality approach. Actually, a good example of how the camera perception, the HMIs, for example, will be driven most of it by the cockpit using the GPU clusters, CPU clusters for having a very engaging HMI. We, in the elite process, added extra GPUs to do the safety systems as well as alongside the cockpit. The AI-powered cockpit, like you saw all those examples, they are running today on our Snapdragon cockpit platforms. They are relying on these NPUs. Again, high tier, like the full NPUs or the small NPUs, audio engines, everything comes together when we put it into the system. ADAS, separate pipeline for the cameras, LiDARs, radars, doing the point cloud processing. All that is put together on the dedicated processing blocks, which will be shared between the ADAS and the cockpit system, but maintaining freedom from interference. And eventually, everything comes together because when you talk about agents, it has to be tied together into one common platform using the information from the ADAS sensors where they are supposed to do a specific job of driving the car, but get that information. You saw that that in the great videos from Thundersoft that was there in Nakul's presentation. How a camera which is designed for doing an emergency braking is using that information to identify a person who was in that black and gray trousers around the corner. This all comes together not just because of the SoCs. We are enabling the agentic AI operating system orchestration, whole of the deployment, bringing on these platforms. We don't need to identify applications. You all are really super innovative in identifying what is the next big thing that you would want to put in the car. Our goal is to be open and enabling the whole ecosystem to bring in these multi-clause, multi-super agents running together either on the car most of the time, or even have an orchestration going back to the cloud. The cycle of what an agent is going to do for execution, how do you orchestrate multi-agents, how do you plan for what is required from an agent, which could be for interaction or it could be even an input going back to the driving, and eventually giving the instructions to the car, which might be an interactive UI or an interactive control system going back to the ADAS. And think about it, this all is designed in a way that it runs on the flex systems where you can use all these implementations as an input to the safety critical applications as well. This comes by experience, this comes by what we have been doing and the industry has been telling us based on the multi-deployments. Now, there is one important thing that keeps coming up, and we have been embracing this, working again with many stack solution providers today in China, globally. The idea of how do we bring more compute? We just discussed that there is a lot of capability requirement for reasoning to come in. Reasoning could be, why did the car did particular motion during the construction zone? Why did it nudge out of the lane? But when you bring VLA into the action loop, you're talking about the token rates to be much higher because you need the action to happen in a specific interval of time, not a long range reasoning, but a reasoning to do the action so that you can predict what is going to happen based on the whole world model, the language model. Needs a lot of compute. Putting compute into one solution and saying this is like a high-end single SoC is one way to solve the problem, but actually still might not solve the complete system problem. So we have been investing significantly to deliver this 2000 TOPS equivalent solution with dual 8797 process. And it's not just trying to tie it together. It is basically to build a system design where you can have a full-blown VLA solution, which can aim to do a level 3 kind of a system independently with the encoders split across the two SoCs and have your end-to-end stack, which is already deployed in most of the cars today, bring it onto one of the processors so that it generates a secondary trajectory. So you can bring a chain of thought reasoning. The VLA models can be mixture of experts. We have actually more than 30 billion parameter mixture of experts that we are deploying right now. This whole system can generate now a primary trajectory, a secondary trajectory, and the safety guardrails that either have already been built over here in China or we have our own active safety stack as well. This is a solution which scales from a single 8797 for a level 2++ system along with a cockpit, expanding to dual 8797 where you can deploy a standalone level 3 solution. And this is where we are working with a few partners, lead partners, to bring the level 2++ urban and level 3 kind of systems on the road very soon. As I come towards the end of my presentation, and really appreciate all the time you guys spent over here, what are the key takeaways? Basically, we have been in the auto industry for quite some time now, and the learnings from giving us an opportunity in connectivity, giving us an opportunity in cockpit, and more recently in the ADAS, all this know-how is coming together into real-world production. That's what we do day in, day out, doing it in the automotive space and going towards more of physical AI implementation. Qualcomm brings one platform that you can deploy here in China, you can deploy as you go outside China. Global readiness with a lot of stacks that are available for specific regulatory requirements outside. That is all available, whether it is for the flex solution or for the ADAS specifically. And as we do all this, we are on the path to higher levels of autonomy. There is a lot more that we are doing, which we would be willing to talk about it in very, very near future. We have been discussing with some of our lead customers and partners on how we are expanding significantly on our computing capabilities. And by the way, it's not just computing. The know-how of system is super important because more than computing, it's the DDR bandwidth, etc., that we need to worry about. And that's what we are working on. I will hold it for a later day. But again, thank you for your time. It's a great show, a lot of demonstrations and vehicles outside, and please enjoy. Thank you very much. Thank you.
感谢安什曼先生的精彩分享。